Friends, welcome to all of you. In my previous lecture, you have studied about quantum numbers, and these quantum numbers are of very much of your importance, so must remember them. I have taught quantum numbers, their types, in a very easy and simplistic manner. So try to remember them with appropriate definition, including examples. And in this chapter we are heading towards end, and in today's lecture, we are going to study some rules. They are called Hund's rule of maximum multiplicity and Aufbau principle. And after the completion of these two principles, we will revise, and we revise from that is just the questions which are given in your NCERT book. On the basis of NCERT book, we will revise all the questions concerned to any point of the chapter. Alright? So let's start with Hund's rule of maximum multiplicity. So what is Hund rule? So first of all, this rule was established in 1925 by Hund. So on his name, this rule is called Hund's rule or Hund's rule of maximum multiplicity. This rule or Hund rule deals with the filling of electrons into the orbitals containing, that is, same subcell or belonging to the same subcell. Listen, this Hund rule deals with the filling of electrons into the orbitals belonging to the same subcell. What is the meaning of this point and what is the statement of this Hund rule? According to Hund, the electron pairing in orbitals is not possible until each orbital of the atom contains one electron. Listen once more. According to Hund rule, electron pairing in any orbital is not possible until each orbital of the same subcell contains one electron. Means that is electrons filled in 3p, 5d and 7f orbitals. Listen, what is the meaning of this statement? Meaning of statement means electrons, pairing of electron in an orbital is not possible. Means pairing means making a pair is not possible until each orbital of the subcell of the same subcell contains one electron. Meaning that since we are knowing that the P, D and F, that is 3p, P, D and F orbital contains, that is 3 orbital is contained by P, there are 5 orbitals in D and there are 7 orbitals in F. Listen, P as you are knowing, in the classification of orbitals, that is p orbital is of three kind, and namely px, py and pz. So that number it means how many kind of that p orbital is. So this 3 means referring to the kinds of p orbital. So p orbital is of 3 kind, namely px, py, pz. Similarly, this number 5 showing that d orbital is of 5 kind. As such, suppose this is your d orbital and they are named dxy, dyz, dzx, dx square minus y square and dz square. You have to read as such: dxy, dyz, dzx, dx square minus y square and dz square. There are 5 orbitals in D. Similarly, there are 7 orbitals in F, namely fx, y square minus z square, fy, z square minus x square, fz, x square minus y square, fxyz, fxq, fyq and fzq. Means this number showing f orbital is of 7 types or 7 kinds. So meaning of this point is that the pairing of electron in these orbitals is not possible until each orbital of the subcell contains 1 electron. Means suppose there are 3 electrons filling in this p orbital as such, then when 4th electron will arise, then it will get paired. This is the meaning of this rule. Pairing of electron will not possible until each orbital contains 1 electron. So here children, 1 and 1 electron containing first they will fill in the various orbital in a sequence. That is, first electron will go in px, second will go in py and third will go in pz. And when the entry of 4th electron will take place, that will come in px and their pairing will take place. This is the meaning of this point. Clear? Suppose in d orbital, so first of all, according to rule, these 5 orbitals which are rated will filled first by 1 electron each. Means 1 electron first fill up there is such, and when entry of 6th electron will take place, then it will be paired here. This is the meaning. Understand? They can't fill as, suppose there are 5 electrons, so you have to not fill this 5 electron in such a manner. You have to not fill this 5 electron in such a manner. This is the wrong manner. So for the prevention of such type of problems, this rule was proposed that electrons in orbital first fills 1 by 1, and then after the filling of 1 electron in each orbital makes pair, so they can be represented as. These are the children very simple things. Just you have to remember the point, remember the definition and listen the lectures twice, thrice. It will be better for you to understand the fact more clearly. So there are 5 orbitals in which first 5 electrons are filled in a sequence, each containing 1, and if the 6th electron will enter, that will come in first orbital, that is dxy, and will be represented as such. And this is the statement. Once again repeating the statement: electron pairing in any orbital is not possible. Electron pairing means making pair is not possible until each orbital of the same subcell, means p subcell, contains one electron. So they are, for example, containing 3, and the fourth will go there, and pairing will take place. Okay, children? So this is the meaning of Hund rule. For example, similarly there are 7 is written, means 7 representing F orbital is of 7 types, and that will start pairing by the entry of 8th electron. That if suppose we are representing 7 F orbital. Suppose this is 7 orbital. So meaning of this rule is that first they will enter, every orbital will contain 1 electron each, and by the entry of 8th electron that will gets paired. That is the meaning. That is the statement. And one thing, why it is called maximum multiplicity? So children, you are knowing that an orbital contains maximum of 2 electrons, and according to the situation of electron, what the electron is present, and maximum electron will filled in the orbital. Suppose we have to write, that is configuration of P6. Suppose we have to represent this Hund rule for P6, means there are 6 electrons in P subcell or P orbital. So first make it as there are 3 P orbitals, means suppose anyone is Px, y, Py and Pz, and we have to distribute this 6 electrons in these orbitals. So 1, 1 and 1, they will fill up first 1, 1, and then rest 3 will get paired as such. So here maximum number of electrons can contain by P orbital is 6, and these 6 electrons are filled in the P orbitals in such a manner. So that's why, and maximum electron is filling in P, means capacity of filling of maximum electron in P orbital is 6. Maximum capacity of filling of electron in D orbital is 10. Maximum capacity of filling of electron in F subset or F orbital is 14. Similarly in S orbital is 2. So that's why they are filling maximum. So that's why this principle is also termed Hund's rule of maximum multiplicity. Okay, children? Suppose once more I take an example. Suppose the question comes that write the orbital electronic configuration of element fluorine. So as you are knowing, fluorine is a 9F, and we have to write orbital configuration according to this rule. So first, go simply children. Don't take any tension. Don't worry. Go through the electronic configuration, and you are knowing that it is 2,7 according to Bohr-Berry. Am I right? And if you are writing this configuration in the case of SPDF system, it will be written as 1s2, 2s2 and 2p5. Okay? Now these electrons which are present in these subcells S and P can be represented in the form of orbital or according to Hund rule. So you are knowing that S orbital is of only one kind and contains maximum of 2 electrons. So this 1s2 electron will be represented as. Okay, this is 1s2 showing. Similarly, here 2s2 is starting. So 2s2 electron containing maximum of 2 electrons. So they will enter as such. And rest, there are P5. So P orbitals is of, as you are knowing, 3 kind, and these 5 electrons of P orbital will go as such. First they will go 1 electron each, that is 3, and rest 2 electron will go opposite side. So this will be the configuration of element fluorine according to the Hund rule. Clear, student? How simple? Don't take any tension. It is very simple for you. And I provided you best lecture, simplest one, that help you to understand the rules or facts very easily. Okay? Just I taking one more example. Suppose we have to write suppose we have to write the orbital configuration of 3d7. Okay? 3d7. So you are knowing that d orbital is of 5 kind and can contain maximum of 10 electrons. Okay? So these are of 5 kind, and namely dxy, dyz, dzx, dx square y square and dz square. So there are 7 electron children. So first they fill up, the orbitals will fill up one by one. So fill the electron. This is suppose first electron, second electron, third electron, fourth electron and fifth electron. And the rest which will come will go in opposite spin, and that is 6th electron will be as such and 7th will be as. These points are very important. Must remember, they will help in understanding the quantum numbers. At the revision of quantum numbers, these points I will discuss you once more. Okay? So must remember how the electron is filling there. So this is all about Hund's law. Now what is the Aufbau principle? That is Aufbau principle or Aufbau rule. So children, Aufbau is the German word which meaning is a building up. Aufbau is a German word which meaning is a building up. And building up means building up of orbitals means filling of electrons into the various orbitals. And building up stands at filling of electrons into the various orbitals of the same subcell termed building up. And according to this rule, this listen sincerely, Aufbau rule is given to fill up the electrons in the various orbitals in the increasing order of their energy levels. And the meaning of Aufbau is the German word which meaning is a building up, and building up stands that filling of electrons into the various orbitals in increasing order of their energy levels. That is the meaning of building up. And what is the statement of the rule? The statement of the rule is, listen sincerely, according to this Aufbau rule, the electron enters into the various orbitals in the order of increasing energy level. Listen once more. Electrons fills progressively in the orbitals in increasing order of their energy level. Once I am repeating this rule or principle. According to this principle, electrons are filled progressively into the various orbitals in the order of increasing energy level. Now statement is clear. Statement of this very rule or principle is, electrons are filled progressively into the various orbitals in the order of increasing energy level is called Aufbau rule, and meaning is that increasing order of orbital energy level means that electrons occupy the orbital first which having lowest energy level, means electron feels first in those orbital which having lower energy and then occupy the higher energy. The increasing order of energy level means that the electron will first occupy the lowest energy level, then it will enter or goes into the, that is, upper or higher energy level. This is the meaning of this statement or this rule. For example, and one thing also know, this model is also known as snake model. Why snake model? Just I going to express you, but before dealing this one, come know the simple example of this principle, that electrons are filled progressively in various atomic orbitals in the order of increasing energy level. So suppose we have to write the electronic configuration of element, suppose nitrogen. So nitrogen is no doubt it is 2,5 according to Bohr-Berry, and in the case of PDF system this can be written as 2s2 and 2p3. Am I right? 1s2, 2s2 and 2p3. So children, why I writing it as such means that according to this rule the energy of 1s is less than 2s, so it is filling first. Similarly, the energy of 2s is less than 2p, that's why 2s will fill first, then p. This is the meaning. One more example. Suppose we have to write the configuration of element sodium, and that is 281. Easily you are right, you can write by the rule of Bohr and Berry. So, and in the case of this Aufbau principle, this may be written as, according to the rule, electron will first fills in lowest energy level. So lowest energy level is a 1s2, then 2s2, then 2p6 and then 3s1. Means the energy of 1s is least and energy of 3s is higher in the case of sodium. So electron will first fill in 1s, then 2s, then 2p and then 3s. This is the meaning of this very principle or rule. Clear, student? One more point. Why this is called snake models, and how you can know the order of energy levels of these various orbitals. So just draw a simplistic diagram by which it will be very easier for you to understand the rule, and you once understand, no problem that you cannot write the electronic configuration of any element. So this in the form of snake model, this can be depicted as snake model. Why called snake? Just I am going to express you. I am writing different various subcells. Suppose I am writing here 1 to 7 s orbitals. Similarly, here 2p, 3p, 4p, 5p, 6p and lastly 7p. And so these suborbitals, these subcells can be represented in such a way, means 1s to 7s, 2p to 7p. The orbitals are represented as, that is 1s to 7s, 2p to 7p, 3d to 6d and 4s to 5s, and they are filled in the form of as such, that is 1s, then 2s, then 2p, then 3s, then 3p, then 4s, and then goes to 3d, then 4p, then 5s. In the same way, means in increasing order you have to go then 4d, then 5p, then 6s, and then 4f, then 5d, then 6p and 7s, and then lastly 5f, 6d and 7p. So this structure looks like a snack. So that's why this is also termed snack model. And filling of electron in the orbitals start from lowest energy level. So in this lowest energy is 1s and highest energy is 7p. So and electron fills in the orbitals in such a way, means they will enter in first of all 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, 4p, 5s, and similarly and so on. So this increasing order of energies of various orbitals can be represented as, listen, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s and up to 7p. So means that what? That is electron fills first in lowest energy level, then reach in highest level, and in this sequence 1s having lowest energy level while 7p having highest energy level, and electron fills in various atomic orbital in this sequence, and that sequence is known as increasing order of energy of various orbitals, and means that electron first will enter in 1s, then will go in 2s, then 2p, and in such a way. Means this representation is the increasing order of energy of various orbitals. So in this order, electron fills in various orbitals. Understood? And this model of representation of electron, as you are saying, that is a Aufbau rule, and this looks like a snack, and the structure is just like a sitting or sleeping snack. So it is also termed snack model for understanding in better way. Okay, children? So this is all about Aufbau rule, and you have to write many electronic configuration based on the principle, and you have to follow this sequence of filling of electron. So for example, suppose we have to write in this very sequence, and according to this Aufbau rule, we have to suppose write the electronic configuration of element scandium having atomic number 21. One element is scandium having atomic number 21. We have to write its electronic configuration in the order of this, increasing order of energy of various orbitals. So we have to write this in such a way as such. As you are knowing, according to Bohr and Bury, its distribution of electron is this one, 2892. Are you sure? 2892. And follow this property and follow this increasing order of energy, or follow Aufbau principle. Then you can write it as such. So first electron will fill in 1s, that is 1s, 2 electron in first cell, so 2 electron is there, 1s2. Similarly 2s2 and 2p6, second cell containing 8 electron, and the second cell electrons are distributed in s and p as such, and that is 2s and 2p. Okay children, just like following this order, first 1s is filled, then 2s, then 2p, and now 9 electron in third cell. Follow this order, so will be what? That is 3s2 and 3p. This is 3s, 3p. Okay, then 4s is coming, 4s2, and then 3d. So next will be 3d1. So this will be the electronic configuration of element scandium in the according to Aufbau rule or increasing order of energy of various orbitals. Listen, this is lowest energy. So electron entering in 1s2, and energy of 3d is higher in this case, so that is filling in the last. So and that all are following this order of this energy level. So 1s, then 2s, then 2p, then 3s, then 3p, then 4s, and then 3d. Okay, this is schematic electronic configuration of element scandium, and that is following the rule of Aufbau and also following the order of energies of various orbitals. And one more point, what is electronic configuration? So electronic configuration is the distribution of electrons among the various orbitals in a sequence is called electronic configuration, children. Okay, must remember one more point, these symbols, these figures which are written are showing according to quantum number, they are showing principal quantum number, and these notations S, P and D, they are showing just what? Azimuthal quantum number L, and these numbers which are written on the top showing the number of electrons present in that orbital, how many electrons present in that orbital, and also in that orbital if electron is present, what is its rotation. All things are hidden in this configuration. One more example, simple I taking. Suppose we have to write the electronic configuration of element chromium 24 Cr. Symbol Cr, atomic number 24, element is called chromium, and its configuration according to Bohr and Baring is what? That is exceptional case, and that is 2813 but it is also according to Bohr Baring it is 2812 two children, but due to some reasons this configuration is not followed, and this is the correct configuration, means 2831. Why is it as such? I will discuss in detail afterward. So electronic configuration we have to write up this element in such a order, so it will be written as 1s2, 2s2, 2p6. Follow the order. In the same way, children, don't take any tension. If you are knowing this order, you are in position to write the electronic configuration of any element. Okay. Next order is 3s2, 3p6, then 4s2 is coming, then 4s1 and 3d5. Am I right till then? This is 24, Cr 2, 4, 10, 12, 18, 19 and 5, 24. Am I right, student? And that is just in the accordance with that increasing order of energies. So, do more practice to write the electronic configuration in this order. Know the rules, Hund rule and Aufbau rule, and also must remember all the quantum numbers, and then you will be in position to understand the facts more better. So students, this chapter is completely this chapter has been completed now, and that is completed in a very simple way and easier way, and from next lecture we will revise it, and that's all today. Thank you, students.